The objective of this video is to show you how you can use your graphing calculator to find zeros of a polynomial function and also to verify that two expressions are equivalent. Let me begin by the easy part and to show that two expressions are equivalent. And these are expressions that I've used earlier on in different videos, so hopefully you will recognize these. So if we want to show that 7x cubed plus 3 over x plus 2 is equal to 7x squared minus 14x plus 28 minus 53 over x plus 2, we can enter the left side into y1, the right side into y2, and either examine the graph or the table to show that those two are equivalent. So let me show you that. So if we have in y1, let me clear out what I have in here, put in parentheses 7x cubed plus 3, close parentheses, divided by, in parentheses, x plus 2. And now I'm going to enter 7x squared minus 14x plus 28 minus 53 divided by, in parentheses, x plus 2. Okay, and let me just start in the standard viewing window. And the graph may or may not tell us a whole lot. What you're looking for with the graph is that those two functions should coincide with each other, and I'll show you a better way that you can do that. If you want to do that graphically, do you see these little slash marks on the left of the equation? What you can do is change those, and that will change the display of the function. So if you press enter, you can go through the different settings. So I pressed enter, and that's going to make that second graph darker. So now let me go back to the graph. And you can see that one is on top of the other, so those are the two identical functions. Now that vertical line there is really not a part of the graph, it's an asymptote, which we'll get into in later sections with rational functions. But the other thing you can do is second graph and look at the table, and you see that at each x value, the y values are equivalent, so you know that those two expressions are equal. We can repeat the process for the polynomials, and that's really an important thing for you to check, because you're going to be factoring these polynomials and you want to make sure that you've come up with the correct factorization. So if we enter 2x cubed plus x squared minus 5x plus 2 on the calculator in y1, and then we're going to show that that's equal to x plus 2 in parentheses times 2x minus 1 times x minus 1. Okay. And again, we can darken the second equation so that we can see those two graphs coinciding with one another, and press graph. Okay, and those are identical. Again, pressing second graph, we see that the table values match up. So pretty easy to verify that those two things are equivalent. Now let me show you the next thing, which is going to be an important way to use a calculator in this section. It is to actually use a calculator to determine the zeros, and then use one of the exact zeros to actually factor the polynomial completely. So it's going to be a little bit different. In the previous video, we were given a factor, and we just had to verify that that was a factor, but here we've got to come up with which factor we need to use. So let's enter this function, x cubed minus 12x squared plus 40x minus 24. So give me just a minute to type that in. Okay, and I'm going to graph it in the standard window, making sure that I have everything typed in correctly. Let's see if that works in the standard window. Okay, we can see the basic shape of the graph. We need to extend it a little bit higher. Let me see what that goes to. Okay, like up to 16 or so. Okay, so let me go back to the graph for a minute. So we need to extend our y max to, we'll say 20. And I'm going to close in on those zeros so we can actually see those a little bit better. So let's change our y or x min to like -5 or something so we can get a closer view of what's happening to the right. So changing the window, we're going to start at -5, keep our x max the same, our y min the same, and our y max we're going to change to 20. And again, it doesn't really matter what the graph looks like, you're only focusing on the zeros, but I think it's nicer if you can get a better picture. Okay, so here's the picture. So remember some things we studied earlier. Degree 3 has at most three real zeros, which this does. So our goal is to find out what those zeros are. Well, to find the zeros on the calculator, you're going to press second, trace, and choose option 2, which is 0. And you have to be on the left and the right side of the zero. So let's go through and find out this first zero that's to the left. So we've got to be on the left side of that x-intercept, which is actually going to be below the x-axis. And we press enter. And then we're going to go to the right side of that particular intercept and press enter. And guess we're going to go between those two marks that the calculator placed and press enter. So it's showing us that one of the zeros is x is equal to 0.764. We'll round that off. Okay. Now we need to repeat the steps to find the next two zeros. So we press second, trace 0, and now we need to move to the right, and we've got to be on the left side of this 0. Imagine a vertical line through the 0, and you want to be on the left side of that. So we're going to press enter. And now the right bound, we need to go to the right side of that 0. And this is where that sign change comes in. To be on the left and right side, your y values have to change signs. Sometimes if you do this incorrectly, you might get an error message that says no sign change, and that's because you weren't truly on either side of the 0. And now we're going to guess to go back between those points and press enter. So our another 0 is 5.236. Okay. And then our last 0, second, trace 0. We need to be on the left side of it. Okay, press enter. And then on the right side of it. And then back on top of it. Okay, and this is 6. Okay, so what we have to do now is use that 0 to actually factor this polynomial. So if x equals 6 is a 0, that means that x minus 6 is a factor. So this is going to put all those pieces together. So we would have to divide x cubed minus 12x squared plus 40x minus 24 by x minus 6. So repeating these steps, x into x cubed is x squared. Multiplying gives us x cubed minus 6x squared. Now we change our signs. And remember, we're changing signs because we're subtracting. So negative 12x squared plus 6x squared is a negative 6x squared plus 40x. X goes into negative 6x squared and negative 6x times. Negative 6x times x is negative 6x squared plus 36x. And now we can change our signs. Adding gives us a 4x minus 24. And so we divide x into 4x, leaves what? Plus 4, so that's 4x minus 24 we knew we get a remainder of 0 because we found that to be a factor. So that tells us that what? X cubed minus 12x squared plus 40x minus 24 is equal to what? X minus 6 times x squared minus 6x plus 4. Okay, we need to factor that further, right? The directions had to factor this completely. Well, x squared minus 6x plus 4 is not a trinomial that we can factor by our hands, right? Because there are no factors of 4 whose sum is 6. But if you know the zeros of that polynomial, then you will know the factors. So this comes again back home. So what we're going to have to do is think about, kind of diverging for just a minute, let's think about what are the zeros of x squared minus 6x plus 4. Well, if we set that to 0, we can do one of two things. The quadratic formula, or we can use completing the square. I like completing the square for this particular one because we have a coefficient of 1 on x squared and an even coefficient of x. So let's do that here. To complete the square, we remove the constant, and then we have to complete the square on the left. So we take half of 6 is 3, squared is 9, and we have to add it to both sides. So this would give us that x minus 3 squared is equal to 5. So that tells us that x minus 3 is equal to plus or minus the square root of 5. So x is equal to 3 plus or minus the square root of 5. So that tells us that the zeros of this function are 3 plus the square root of 5 and 3 minus the square root of 5. So the way that's going to play a role here is now we can go back to the complete factorization to say that this original polynomial is equal to x minus 6 times x minus 3 plus the square root of 5 and x minus 3 minus the square root of 5. And if you want to simplify that further, you can say that's x minus 6 times x minus 3 minus the square root of 5 and x minus 3 plus the square root of 5. And all I did there is distribute that negative sign inside. Okay? So you had to use a lot to come up with the result of this problem. So let me just review the steps that we took. I used the calculator to find the zeros. We found an exact 0. So finding that exact 0 told me what a particular factor was. I had to divide the original polynomial by that exact 0, or exact factor. And in doing that, that gave me a quadratic polynomial that was not factorable by hand, which I told you earlier they should all be, but this particular one was not. And you may encounter some of those in your exercise sets as well. So what you would have to do then is use some method to find the zeros of this polynomial. When you set that to 0, I used the square root property to find the zeros. Finding the zeros then told me what a factor was. And so the complete factorization is one of these two results here. Okay, now how can you verify? You can use your calculator and make sure that 3 plus the square root of 5 and 3 minus the square root of 5 are those other two zeros that we found. Okay? So if you have any questions on this, please don't hesitate to contact me.